Welcome. Sydney Water's been embarking on high-rise water efficiency programs for a long time, ever since I started 10 years ago. But really our focus was a bit of a shotgun approach. It's only in recent years that we embarked on a pretty serious research project, which Mel's already referred to, where we specifically looked at what is going on within a high-rise building and with the objective of working out what the difference is between an efficient high-rise building and a less efficient high-rise building. And the outcome of this is some benchmarks, which I'll talk about shortly. The other thing I want to mention towards the end of my presentation is we've also done a lot of work in response to growing community interest of individual metering of high-rise apartments. Now, this is a big challenge and there's a lot of technical as well as social issues associated with it. So I'll try and peel at least one layer off the onion, so to speak. It's got many layers of complexity, and it would need much more time than I have here today to go into that detail, but I'll start at least opening your eyes to some of the challenges that at least Sydney Water are trying to deal with. So first of all though, just trying to set some context why on earth Sydney Water is still banging on about water efficiency despite the weather we've had recently. Excuse me. Clearly, the demand is pretty secure at the moment. We have a weather-independent desalination plant. As you can see here, storage levels are trending up pretty steadily. Not quite what they were in the late 1980s, but they're not bad either. Essentially, I'm not sure how many of you are aware of the desalination plant is about to be sold on a leaseback arrangement. And those tender documents were made public last week. But one of the pitch points for a potential buyer of the desalination plant is that it has a design life of 150 years. Right? This is a long-term, durable asset. So this is a thing that's weather independent. It's as solid in terms of performance as a dam. So these things in combination help increase the security of supply in Sydney. On top of this, demand is very low. It's never been lower since the 1950s. 1954, I think, was the last time demand in Sydney was this low. So 25 years of demand reduction, and population has gone up. I'm trying to think of the number now. I think it's 21%. So demand has dropped 25% and population has increased 21% in this period. So clearly, secure supplies, low demand, is there really an issue? The issue is prices are rising. For two things. Water is a capital-intensive business. Desalination plants need to be available, dams need to be available whether it's raining or not. The pipes, pumps, treatment plants, the sewage treatment plants, all that infrastructure needs to be maintained and operational regardless of how much water's flowing through them. If the less water's flowing through them, then there's less revenue to pay for that maintenance, and therefore it's one of the key drivers for prices rising as well as inflation and so forth. But clearly, when I started, we were dreaming for the day when water hit $1 a kilolitre, so then people would have some incentive to save it. Now it's over $2 and it's still increasing. Just last week, or in the last fortnight, Sydney Water's put a submission to IPART, so that shaded area represents the prices that we've submitted to the IPART. It's up for public discussion and so forth at the moment, but those are the proposed prices in the future. But it's not just water. Prices are increasing. No doubt anyone that pays an electricity bill would have noticed in the last quarter a significant increase, I should say, of 17% in the last quarter's bills. Many are getting close to Christmas now. Most of you would have received your first quarter for the 2011-12 financial year. This is a diagram that explains what drove those prices. And once again, it's the capital-intensive portion of the business that is driving the costs, as well as obviously the cross-subsidy that has occurred with the solar bonus scheme and so forth, the feed-in tariffs. But the biggest single expense is the poles and wires, just that critical infrastructure that must be maintained regardless of how much energy is going through it. So why is water and energy a particular issue in a high-rise building? Because in most high-rise buildings, or in Sydney at least in all high-rise buildings, the mains pressure doesn't get the water above about the 4th floor. Beyond that, it has to be pumped. So In most building designs, in fact, they don't even bother trying to use gravity to get it to the fourth floor. They have the pumps situated on the ground floor, and it all starts from there. You're adding more and more energy into your water from the point it enters the building, essentially in a high-rise building. So straight away, there's a correlation with high water use means higher energy use. Every drip that's on the top floor of your high-rise building was pumped. Okay, and if it's a hot water tap that's dripping, it was pumped and heated, and then it goes to waste. So this is why energy is intrinsically entwined in water conservation in high-rise buildings. To give you an idea, there's not a lot of data here of the energy intensity of water throughout a high-rise. We're getting very close to reaching that point. That's why there's a lot of emphasis on monitoring in the City of Sydney's future program and in Sydney Water's recent research. This is another publicly available document that went to the Productivity Commission from Sydney Water. It's a metaphor, so to speak, for the energy intensity of water in a high-rise building. But essentially, the document where this came from was trying to explain, where for every $1,000 that the community puts into Sydney Water, this is where we put the money. And everything that's shaded in red there is energy intensive. Okay, you can see already that the water that comes to your ground floor before it's pumped and heated and all the rest of it already has treatment costs associated with it. A portion of it, especially in the city, has got a significant proportion of desalination energy going into it. The transport, pumping transport, is a significant input, but also a big driver in that is the actual pipes and the maintenance of them under roads and all the rest of it. And you've got the retail section, the bit where I sit. My wages are part of that $30. Cheap, really, aren't I? And then you've got the wastewater side of the business. The wastewater's got to be transported to the coast and treated and so forth, or treated inland, depending on where you sit. Anyway, so it's just going to show that Sydney Water is an energy-intensive organisation. We're one of the top 10 energy users in New South Wales. We also have a carbon neutrality goal in 12 years' time. So it's a metaphor that the energy that you use every day already has a significant energy input. The water you use every day already has a significant energy input. Now to the research that we've done, alluded to already by Melinda, and it's getting a little bit old in terms of being new research. It was first released in about May this year. But I'm assuming not many of you have heard about it. It wasn't broadly broadcast about it, the results of it. But essentially, we went and did detailed auditing of 22 residential towers. In doing that, we looked at a large proportion of the apartments and looked at what appliances and fixtures and monitored some behaviours as well. Essentially trying to look at where water is used in the apartments and the level of efficiency of taps and showers and dishwashers and washing machines and so forth. We did our best to sub-meter, so put additional meters in and remove all the common areas, the air conditioning if there's cooling towers, and anywhere that was obviously not residential. And in some cases, we were able to put sub-meters on various levels of the building. So the top half of the building was metered separately from the bottom half, or maybe several segments were able to be metered separately. The complexities of doing this I'll cover later, but relatively, probably by far the most detailed monitoring of a large sample of high-rise buildings. The work was done between 2009 and 2011. And then, obviously, it was a natural progression for us having delivered our retrofit program, which is a shower head and tap and leak repair efficiency program for over a decade. When we saw opportunities, we promoted heavily the retrofit program and got as many quick and efficient savings as we possibly could, all the time monitoring so we could measure the impact and benefit of doing these activities. What was a bit unfortunate is being a water organisation, we weren't able to get, and the high rise has been spread all over Sydney, we weren't able to get enough interest from the energy retailers to do some detailed and/or pay for some detailed energy monitoring. But that is happening now in the future City of Sydney program. So what did we find? A few slides here of the results of the sort of forensic results of the monitoring that we did. Really the main take-home message though is up to 90% of the water is used inside apartments. It surprises most people when this was first uncovered. You can see in the bottom left-hand corner there, apartments represent 39% of water use in apartments alone. And that's, again, why the water fix program was a perfect fit. Its hero product is quite simply a water efficient shower head. Toilets, 10% basins, 9% bath, and it goes on and on and on. As you go clockwise around this pie chart, it's only the smaller segments in the bottom right where you start seeing traditionally non-residential water uses. And the leakage was highly biased towards in-apartment leakage, though when we did find big leaks, so single leaks that were big, were often in a common area, in a hidden duct, and just draining into a hidden drain, and absolutely no awareness in the building of that leak. So this is why monitoring even of the single metre in a building is really important, and integrating that into your building management system or so forth. So at least you can tell that consistently between 2 and 4 a.m. you've got flow, when really you shouldn't have significant flow. If that's the only thing the master meter tells you, it's already going to save you tens of thousands of dollars a year. So in response to all this monitoring, we found a whole range of opportunities. Clearly that was one of the objectives of the program. Most of these opportunities were in the apartments, but several were associated with cooling towers and other associated water uses. The typical savings per site, and really the majority of the fixes we implemented were either major leak repairs wherever we saw them, but most of the stuff was covered by simple plumbing tune-up, water efficient shower heads, tap repair leaks, water efficient taps and so forth. These sorts of savings, $4,640 worth of savings, that was in last 2 and 3 year prices, not current dollars, and 61,000 litres per day. That's the sort of savings you can get for really, really low spend, really simple no-brainer. This is the sort of payback we're getting in terms of how long it takes to recoup the cost of what we implemented. Some of them were measured in days, like less than 90 days. And it's because of the energy use in hot water, in shower heads and taps, the warm water that's used in showers and taps has a significant contribution there. And again, up on the slide is the greenhouse contribution savings, because again, every drop of water was pumped, and then some of that was also heated, so you get big carbon savings by saving water up in high-rise, regardless of how you save it. And the further 225,000 tonnes is related to the pumping of the water to the apartment, so again, extolling the benefits of that savings. So to try and map the 2 bits of information I've given you together now, where the first chart told you about where the demand was. This shows us where the water savings were. So where there's a strong correlation of savings as well as demand, so high looking low flow shower heads, they represented 44% of the savings, and they're also nearly 40% of the demand. So that's a really strong correlation there. You're getting big bang for your buck just by installing water efficient showers. Again, just in case no one knows what a water efficient shower is, it's less than 9 litres per minute. Get a bucket and a stopwatch, and you can work out whether your shower's running at 9 litres per minute or not. And then I've just highlighted a few key ones where the demand is high and the leak opportunity was also high. So anything that's blue there, so it's the flow regulators in kitchen and taps, repairing of leaks, flow regulators in bathroom taps and lower flush toilets, as well as showers, of course. So the king opportunities where you're going to get money for jam, really. Really quick paybacks, really low investment costs, really quite simple things to implement. So why wait? Start saving. Essentially, this is just a pitch for a program which I've run now for 11 years, engaging nearly 1 in 3 houses in every suburb in Sydney. Water fix program. The price has gone up. It's no longer a subsidised program because it's got such a huge penetration. And we know the paybacks are still incredibly good. But this is the sort of price that Sydney Water can charge, and we've organised a bulk rate for high-rise buildings depending on how many appointments we can fit in a day. It's ideally suited obviously for a high-rise building where you've got a coordinated approach. We can reduce our costs significantly. But again, in our apartment we've measured this where we're replacing single flush toilets and doing a standard water fix. We're getting in the order of 40,000 litres per unit per day savings. Again, that's for about a 2.5 hour appointment, including a toilet replacement. Benchmarks. Okay, this is probably the best key takeaway message, and I'll end up drumming it home to you as I continue my presentation. But essentially, none of you would really know, even if you had your water bills in front of you, how you compare to your neighbours or a similar building down the road, or even a different size of building, or one of the buildings that we've already optimised. So benchmarks do this for you, okay? What you need is a proxy for per person or per building water use, and that's the first thing we did in this research, is try and test a whole range of proxies. So you get water use is easy to obtain. You get it in your bill every quarter. Some with a high commercial tendency will also get it monthly. But the other variable is it's water use per something, per bedroom, per person, or whatever. It's very hard to measure the population in a high-rise building. It's very hard to measure other protocols or other parameters, or it becomes less relevant depending on you can't compare across a range of different buildings. So with this diverse sample we had of 22 buildings, we determined, based on the data we had available to us, that a per bedroom benchmark was easy to obtain, easy to measure, and relevant across a wide, broad cross-section of buildings. So this is, a robust, general purpose benchmark that you should all be able to use. I'll be very surprised if there's many exceptions. It's litres, it's measured in litres per bedroom per day. So the hardest thing, obviously, you only have to do it once, is to work out how many bedrooms are in your apartment. Obviously, that's a proxy for the population, which we have worked out is already too hard to measure. And once you've got those two, or that single variable with your water use, you'll be able to work out a benchmark and you'll be able to see where you stand. So the appropriate benchmark, the other benchmarks we tested was a per apartment and by net lettable floor area, which is a common commercial building benchmark, and gross floor area. You can see why residential high-rise building population is a big driver. We can't measure population, so the next closest thing was per bedroom. The other good thing about per bedroom, if you know you've got efficient fittings and you've done all your audits and you know your building's in good order, and you still have a very high per bedroom water use, you've probably got an over-tenanting issue, a big over-tenanting issue, which I know some buildings in the CBD do have. So how does your building rate? This is probably the crux message, is where you sit. We, in our high-rise pilot program that we did, the research, we had some very inefficient buildings. We implemented the water fix program and fixed all the major leaks, and we achieved what's up here as best practice. So we've seen it happen cost effectively, and we've transposed buildings from very inefficient to very efficient in a matter of weeks. So we know it's possible, and that's why we're quite confident in these benchmarks. And having said that, we've also got an unachieved target there. We weren't 100% successful in getting water fixes through every apartment. We weren't 100% effective in sub-metering all aspects of the non-residential use and so forth. So we know there's some opportunities that are out there still left outstanding. And so we think we can even go below what we now believe is best practice. This unachieved target is really where buildings can be striving for. I don't believe there'll be many buildings there yet. We've measured some of even the most recent modern buildings, and they're sitting typical or best practice. They're not sitting below the best practice level that we've seen. So one more sort of justification, it's the smallest range across the buildings. It helps confirm the impact of over-tenanting and accurately reflects efficiency gains. Okay, because once again, the efficiency gains that we're recommending most strongly are in apartment efficiency gains, and there's obviously got a direct correlation to the people in the apartments that are using those fittings and fixtures. Okay, it's a bit of a diversion. The individual metering, I know, is a touch point, and Sydney Water's only recently gained a lot of confidence in what we're going to do to address individual metering on new buildings, and some of that policy development will apply to older buildings to certain extents, differing extents depending on the complexities or the hydraulic design of these buildings. So the first thing I need to get out there, and I'm sure you're already clear though, is that if a building wasn't specifically designed for individual metering, it can be incredibly complicated and frustrating to install individual meters in an existing building. It's as simple as that. It's not Sydney Water's fault, it's not the developer's fault. It was just when these buildings were built years ago, it wasn't a driver. It wasn't ever anticipated as being a strong issue. Water was cheap then, water had been cheap for decades, and there just wasn't any expectation that there would be a need to arrange the hydraulics for individual metering. And as it happened, individual metering requires significantly more plumbing infrastructure in a building. So unless you're individually metering and carefully monitoring, all this additional infrastructure has the potential of having more hidden leaks that, in cupboards or in vacant shafts and so forth. So unless you're monitoring it, you're actually increasing your leak risk. So now that the technology of monitoring is much better, City Water is much more confident in recommending individual metering. So this is a schematic. I've got a couple of schematics. This is just a bunch of diagrams, not too much more talking. A typical high-rise building, one of the main problems is that the water supply goes either vertically through all the bathrooms and laundry, or up through next to the elevator shaft, or there's a single riser going up. All the water's pumped to various tanks and so forth. It's generally heated centrally, maybe not heated in many cases as well. And then you'll have your common uses split off separately. Sometimes if you have a pool on the 5th floor or something like that, I know some buildings do have pools on the roof or in the middle of the building, or other common areas. It gets further complicated because in the middle of the residential portion you've got a common area, and so you need to put 2 metres on to split the common area, the residential portion above or downstream from that common area that's midstream. Anyway, this is a typical plumbing layout. So each floor, you basically have a ring main going to each apartment. A solution here would be to have individual meters. If the ring main's going past everyone's front door or through everyone's kitchen, is to have a bunch of sub-meters at each apartment's point. But what the problem is where those sub-meters can be installed. If they're in the apartment, no one can read them except for yourselves. They need to be outside of the apartment so they can be read by someone. And clearly what's really common is you can put a common meter on your common areas, so at least split off car wash bays and pools and gyms and so forth. In many cases, that's the first logical place to put a sub-meter, is to try and split the residential use from common area uses. But this diagram looks nice and simple. In practice, it can be horrendously difficult. This is an example of an ideal situation. A cupboard at the end of the corridor. Typically, it's the shaft where the pipes rise through the whole building before they split off to each apartment. That's where you could put a bunch of meters. The dark blue circle being a vertical view of the rising main going up through the building, and the blue circles being sub-meters for each apartment. Again, a nice simple schematic. Where these pipes run is typically through concrete walls or under concrete floors. To modify them is a real challenge in some cases. But the critical point is that the meters that are able to be read in a common area, so the building manager can read them, City Water can read them, or we can wire them up and they can be read at least centrally down on the ground floor or something like that. They can be replaced. The meters only last about a decade and then they need to be replaced. We don't need to come and get access to apartments and all the rest of it. There's a whole bunch of reasons why meters in common areas are really the only practical solution. This is another solution which is more common in new apartment buildings, but it could potentially be possible in old buildings that have mail slots and laundry chutes and all the rest of it. You can route your sub-meter, your individual apartment meters, in a void that's on the boundary of the apartment and the common area. So again, it can be accessed via the common area for replacement and monitoring and maintenance and so forth, as well as reading, but not too disruptive. This would be an example of just in a 3D view of how it might work. How we don't want it to work. This is a short-term fix, having a meter inside an apartment, all well and good, get it installed, but you're relying on the tenant or the resident to read the meter for you. When it needs replacing, it's going to be very difficult to get access. It's generally replacing a meter is a fairly messy job. A fair bit of water runs everywhere while they're doing it. A whole bunch of reasons why City Water doesn't want the meters inside apartments, and if we do, we certainly wouldn't. It wouldn't be a Sydney Water meter. If a meter's installed in an apartment, it'll be a body corporate's meter, and it'll be their responsibility to maintain and read. Last slide. most important thing really that I've mentioned today is these benchmarks. They're worth remembering, that they're worth keeping an eye on, and that it's worth the effort of finding out how many bedrooms are in your building, because that's all you really need. That measured, that matched up with your quarterly water bill, and you can work out where you stand. The higher you are from best practice, the more cheap and inexpensive and simple the fixes are to literally put money back in your sinking fund. It's really a no-brainer. It's very simple, low skill. It's barely plumbing skill. A handyman could do much of the work that we do in a water fix program.